Welcome to the CHCH Newsmakers podcast. I'm your host, Rick Zamperin. If it's making news in Hamilton, Halton, and Niagara, across this great country or around the world, you're going to find it on Newsmakers. Prime Minister Mark Carney has called it one of the most intense wildfire seasons in Canadian history. Extreme heat waves and dry conditions this summer have triggered hundreds of wildfires across the country. What's causing this increase? And even more importantly, can we stop it? My guest today is Sarah Styler, an associate professor of chemistry and chemical biology at McMaster University and a Canada Research Chair in atmospheric chemistry. You're doing a lot of research these days on wildfires and other stuff as well.
Yes, this is true.
So why are wildfires in this country becoming more prevalent? What are we seeing?
Sure. I mean, this relates to climate change. And so what's happening as our climate warms is that we're getting conditions that are more amenable, I suppose, to wildfires happening. So the natural triggers that were always there in terms of lightning, and then less natural triggers like people, using their ATVs and sparking things in wilderness areas are just, it's easier for that to turn into a wildfire now because it's drier, it's hotter, etc.
Because it is so dry, and let's just take, somewhere in northern Ontario, it's super dry up there, not a lot of rain. Apart from a lightning strike or a human-caused wildfire, can a slice of grass just erupt in flames? Like, how does that work?
Oh, I mean, that's a good question. I think there needs to be a trigger of some sort.
There needs to be something, okay.
For sure, yes.
Okay, so it's rapid sunshine, something catches ablaze, and here we are.
Yeah, I mean, it would be something like a spark from an engine or a campfire or things like this. I mean, this is why there's such stringent campfire restrictions and burning restrictions in place. They're really important because it's a much larger chance that things could kind of get out of control.
So these and there's hundreds of them across the country. There's nearly 200 of them in Northern Ontario alone. From a chemical standpoint, we've had air quality concerns and issues, obviously. What is happening with that particulate matter?
Oh, sure. So when we have a wildfire, I mean, it's like a really, really, really big campfire, right? And so when you're out in a campfire and you don't want to sit directly downwind of the smoke, it's more or less the same thing. So we have a variety of different gases released because what's happening is we're burning this biomass, so trees, the components of the forest floor, etc. And we're not burning them efficiently like we would in a really high efficiency, fireplace or something like that. In often cases, they're smoldering, especially with boreal wildfires, because there's the peat on the forest floor that's also a fuel source. And so they're burning kind of inefficiently, and that leads to release of carbon monoxide, a lot of different organic gases, some of which are toxic, benzene, things like this, and then also particles, because we're not converting everything just to CO2. And so the particles themselves have a lot of toxic materials contained within them. And because they're quite small, they can end up in our lungs when we inhale them. And so that's the main thing we're concerned about during these wildfire smoke episodes.
And once they're in the air, they're out of our control. Like, they're going where they're going to go.
Yes.
Yeah.
That's true. And it's in large part because they're so tiny. And so the particles that we hear about a lot in terms of air quality issues are PM 2.5. So particulate matter, PM, smaller than 2.5 microns. And so this is something like, I forget the exact number, 20 or 30 of them fit across a human hair. So they're really tiny.
Okay.
And if we imagine things settling out of the atmosphere, if we throw a bunch of sand into the air, it falls out right away. But if we throw tiny little particles, it takes them a really long time to sediment out of the atmosphere or to be washed out by rain. And so what this means is they can go very far wherever the prevailing winds will take them.
Right. Do we know how far they can go? Has that been measured?
Sure. Yeah. I mean, particles in the atmosphere can be transported really far. So, for example, when I was living in Alberta, we would get wildfires from Montana. When I also do some work studying dust in my research group. So little tiny dust particles can make it all the way from the Saharan desert all the way over to the Amazonian rainforest, across the ocean, and deposit there. So yes, particles can go very far.
Yeah. So
you're small ones. Yeah.
You're studying particulate matter and a host of other things as part of the particle research group. Tell us about your research.
Sure. So particles was coined by someone in my, I think Iris in my research group, because we wanted, in my field in atmospheric chemistry, we really like acronyms of various sorts and trying to squeeze things into these. So particles at the moment stands for to be completely honest, I can never exactly remember.
There's a lot of parts to the particulars.
There are. And one of the things we liked about the name was that we could just shuffle in new things as students join the group or leave the group, etc.
Okay.
And so we do a lot of work related to chemistry that happens on surfaces in the environment, really, really broadly defined. So these could be surfaces like wildfire particles. They could be surfaces like windows or other parts of buildings in cities. They could be things like cultural heritage objects, so paintings, sculptures, things like this, and also microplastics. And then I feel like I'm forgetting some things. Pesticides on surfaces. There's a lot of stuff going on.
Yeah, brake rust was one of the ones where So what are you studying? Like, what are you looking for?
Sure. So what we like to look for is a really kind of fundamental understanding of the chemistry that happens on these surfaces. So, for example, in the case of wildfire stuff, which I guess is obviously the most topical, we were interested in thinking about after these smoky days and the smoke is gone, is there any sort of leftover impact on the environment, I suppose, in cities. Okay. And so we actually took some really simple samplers and deployed them. This was in... which year was this? 2023 and 2024, I believe. And we sat them outside. They were glass beads, which are sort of like windows. Okay. And we left them after some wildfires. And it turns out that really short wildfire smoke incursion, so the smoke coming through, can actually contaminate the surfaces with all of the gunk that kind of comes out of the smoke. And so basically what this means then is if we have a really polluted weekend or week or whatever, we could see a trace of that in cities for much longer afterward. So we're not breathing in the smoke anymore, but the surfaces in the city have some residue from the smoke.
Right.
And so that's one of the things we've been looking into.
Did you find out what the gunk is, and is that different all the time?
Yeah, this is a good question. So this is one of the major topics in my group right now is this, we call it urban grime, with the name reflecting the complexity, I suppose, of the material. And so grime contains a lot of different things. It contains dust from roads that gets sort of resuspended and ends up on surfaces if you ever have to sort of clean your buildings. Right. It's that kind of stuff. And the wildfire is just sort of an extra sort of bonus item that can also, the smoke can also stick to those surfaces. Yeah. And so in terms of the composition, the things we've been looking for are what are referred to as polycyclic aromatic hydrocarbons, PAHs. So soot and black carbon, so like the sooty black stuff, is really, really, really big polycyclic aromatic hydrocarbons, where the poly is like a lot. Smaller versions of that, those molecules, that's the PAHs. And so they're quite toxic. And so they're regulated. And those are the things we're worried about. Well, a fraction of the things we're worried about when it comes to wildfire smoke, because they're toxic and in some cases carcinogenic. Right. So we were quantifying those in these urban windows, essentially.
And has your research led to either any policy changes or discussions at upper levels of government say, this is happening, we need to do this?
I mean, I would say that the work we do is, with respect to wildfire research, at least, I would say is pretty fundamental science, like basic science, understanding things, and data gathering, I would say. Some of the things we have more control over, though, are other sources of emission, like industrial emissions and things like this. And so my group has been doing a lot of work in a Hamilton context on this grimy material, not really for wildfire's sake, but rather for industrial pollution. And so we had a large study with Environment Hamilton called What's the Grime? And we were putting samplers around Hamilton at 50 different community member locations to look at the dust fall and to characterize that dust fall around the lower city.
Okay. Were there worrying areas or areas that worried you in terms of the grime collection?
Sure. I mean, I guess, I don't know how much you've been talking about this soot issue on the news.
We've had it, yes.
Yeah, okay. So this
quite the concern.
Yeah, the most recent stuff. Yeah. So that's sort of like, what would I call it? episodic type events like that really get the attention, right, of the news, and rightfully so. I think there's sort of an ongoing pollution emission into these neighborhoods, though. And when I say these neighborhoods, I also live in the lower city, so I'm very sort of have a vested interest in these kinds of issues. And so what we have found is that with collaboration with our volunteers across some of the different city wards, that the pollution levels, the levels of these polycyclic aromatic hydrocarbons, so they come from combustion. They could be combustion of an entire forest, or they could be combustion from coal in a power plant or some sort of industrial manufacturing facility, right? And so we found that those levels are much higher closer to the industrial areas, definitely. And this just really tracks with what residents have been saying for eons, essentially, right? Is that the neighborhoods that are way, way, way up on the mountain are not having black soot fall on their houses. That's happening closer to these industrial areas.
Right. In terms of the wildfires, is there anything we can do to prevent them or minimize their impact?
Right. I mean, I think that this increase in fire weather is a big part of the reason why all of this is happening. Right. And so on an individual level, I don't want to be defeatist, but we need collective action to solve climate change, right? This isn't an individual purchasing decision kind of issue,
right?
And so, in terms of what we can do, I think that the causes are broader than one person, but the protective things we can do, we can do them on an individual level. And so, I think it's really important for everyone to pay attention to the Air Quality Health Index, AQHI. And this information is presented, I think it's now on the Weather Network. It's become much more sort of publicized, I think, than it used to be. And so these levels are designed to make it clear what kind of activities people can take part in safely outside, whether they're a member of the general population or people who have pre-existing health conditions who are more susceptible to the effects of inhaling this particulate matter. And then, so for example, my son, he's 3, and he has reactive airway disorder, which is like an asthma precursor. He's too young to get the official asthma diagnosis. And so he plays soccer outside. And so his soccer game was canceled last Wednesday. But even if it hadn't been, I wouldn't have sent him out for that. And so the guidelines are there to sort of give a sense of what activities you can participate in. And then there's always masks, just a throwback to the days of COVID, right? I think that our collective understanding of particulate matter and us are the ways that our inhalation can affect our health is much more
top of mind.
Yeah. And so I think, when it's smoky, pull on, break out the mask again. Yeah.
And 95s will do you well.
Exactly.
You said we need to do a better job as well. Is that beyond, reusing, reducing, recycling?
In terms of
minimizing these, impacts or these occurrences?
In terms of the context of climate change?
Correct, yeah.
Yeah, I think that there's this individual action in terms of thinking about our consumption habits and things like this. But on a broader level, it's more of a policy change issue as we move toward electric vehicles and we're reducing emissions from combustion engines, as we put in more sustainable manufacturing processes and deal with all of these sources of carbon dioxide to our atmosphere, which is the main driver of climate change. These are big picture decisions, like governmental decisions. Right. So advocacy on an individual level is definitely helpful. I think just sort of expanding the criteria for how governments and companies are making decisions to include these outcomes, I suppose, or these negative impacts is very important.
Right. From a firefighting tactical standpoint, if you will, is there anything chemically we can do to fight these fires as opposed to just throwing water and I guess they use retardants in some areas as well?
Oh, gee. That's a good question. I think that if we're talking about fires that are close to different, human settlements, so this is referred to as the wildland urban interface, where, you get fires that are abutting right up next to cities, essentially, then it's sort of a firefighting issue, right? In terms of the boreal forest, I mean, it is a very big forest, and so it's not like there can be constant inspections in every single location to tidy it up or something, right?
Yeah.
Especially the boreal forest, the forest fuel, the fuel that is driving the fires is the forest floor. It's peat. You have these areas where you have conifers, so you've got your spruce, whatever, etc., and those burn, of course, the crown fires. But then you also have this smoldering peat, and the peat has built up there over time immemorial, right, from a decay of organic matter. It's very spongy. I don't know if you've ever walked on peat before.
I have not. I've seen people walk on peat or lie down on peat because it's like a mattress.
Yeah, it's like
almost.
a bouncy castle, kind of.
And so this is really adding fuel to the fire or keeping the fire alive.
Yeah, exactly.
Back to your research. What are you working on next? What's the next big thing?
Oh, sure. Well, we have some microplastics that are deployed in Hamilton Harbor at the Canadian Centre for Inland Waters. Josie in my research group, she's a PhD student. She is working with researchers at CCIW to put these little plastics in the harbor and see what kind of pollutants they collect, and then look to see how sunlight is affecting the chemical reactions that happen on those plastics. So she has this little device that's hanging out in the harbor. She sent me a picture yesterday, and it's interesting because we wanted to measure, again, these PAHs, polycyclic aromatic hydrocarbons, in the samples that were exposed to light and not exposed to light. And so when she brought it back in, the ones that were exposed to light were actually also, as a bonus, covered in algae, actually, because, the algal blooms, algae require sunlight, right? And so anyway, they're a bit gunky. We're going to analyze them, see what happens. So that's sort of really hot off the presses, as in she sent this to me yesterday.
Oh, wow.
The other thing we're doing is we have, amongst many, is we have, I've actually started a startup, which is foreign to me because I'm not really a business type, where we're developing an instrument, a piece of equipment that can help art galleries and curators and art handlers and everyone who works in sort of the cultural heritage field decide how they store their artworks. So what kind of materials do they use to put for boxes that surround paintings or for frames. If you go to a framing store, you would hear about things like acid-free mat board and, all those different things you can make those decisions. And so in museums, it's like that times a lot because museums have obviously huge collections and there's a lot of museums. So we're trying to work with cultural heritage professionals to design a little kit that can help them make those decisions really quickly. Is this safe or not safe?
Yeah. Back to the water experiment and finding out what's in the water. What's the hypothesis in terms of what you hope to find or think you're going to find?
Yeah, this is, again, one of these studies that is, it's related to this topical issue in terms of microplastics, but it's really motivated by these kind of basic science questions, which for us are, if we have plastics, plastics are... because a lot of contaminants in the environment aren't really water soluble, they sort of stick to the plastics. Like there's a little bit of them in the water, but they like to be in the plastics more. It's kind of like an oil and water sort of thing. And so when the contaminants are in the plastics, we want to know what happens to them because in plastics, contaminants, the plastics can get eaten, and whether or not animals eat them or not depends on their color, their shape, like all these different factors. And so what we wanted to know was how does the sunlight that the plastics experience as the plastics are bobbing around affect the contaminants that are stuck on them? So our hypothesis was that the sunlight would change the composition overall, holistically, of the contaminants that are on the microplastics. And so the idea is we need to know what's on the microplastics because this is sort of kind of, I don't know, contentious is the right word. It's still discussed in the science literature. If you eat microplastics, what's causing the harm? Is it the plastic themselves or is it all the stuff that's hitching a ride on the microplastics? So that's where we're coming from with that. So it's kind of like a niche science question with the goal of kind of helping people understand some of the results they get in their studies. Like, for example, if you measure stuff and you don't consider the sunlight, has that affected what your results in ways you haven't thought about? So is that going to lead to a much bigger study in terms of microplastics? Well, this this one is kind of our little bit bigger one, actually.
This is the big one. Okay.
Well, because we don't do a huge amount of field work. I mean, I mentioned that we do, and field work being like going out and doing measurements in sort of the real world.
Yeah.
We definitely started, and I started my career as a laboratory scientist. So I would go in, I would do the things in the lab, and then I would try and connect it to the real world. And my research group, as I'm kind of continuing on in my career, is moving a lot more to these real world situations. Okay. So this is sort of just one example of how we're trying to get out and perform measurements in the real environment, which is obviously hugely more complex than the lab. So I could list for you, like in the lab, we have water and we have plastic, we have contaminant, like single things. And we study those because they help us understand things on a really basic level.
Right.
But in the real world, we have to figure out like how to translate that information into results that are important outside. So you really have to have both sides of that equation, I suppose, to understand things. So in the harbor, for example, we don't just have one type of contaminant. Hamilton Harbor has been blessed with a lot of different contaminants, Yeah. And it also has light, and not just lab light with like one wavelength, but like the whole solar spectrum. It has biological activity, the algae I was mentioning, that can affect things in really complicated ways. It has differences in pH, the list goes on, differences in light levels, et cetera, et cetera. And so we need both of those ends of the like complexity scale, I think, to understand these processes, I would say.
Right. Do those real world experiments mean a little bit more because there's so many different dynamics to it?
Yeah, they both have their place, I would say. So the way that things work, at least in atmospheric chemistry, which is my original sort of area, is one of my mentors, John Abbott at the University of Toronto, referred to this as a three-legged stool in terms of how we think about studying these problems. So the first is the lab, where you do the simple things that give you hypotheses for what to investigate outside. So for example, our indoor stuff gave us the motivation to do the outdoor stuff because we saw the light effects in the lab, right? And it's a lot easier to just mix stuff in the lab than it is to like, hello, can we put this sampler at CCIW and then have it covered in algae, et cetera, Yeah. And then the second part of these field studies, and they give us a bunch of information, but there's so much happening at the same time that you need that fundamental understanding to understand what's happening outside. So then there's the third one, which is modeling, environmental modeling. So what it does is it takes the values you get inside, the simple stuff, and it puts it into different mathematical models to see if you can result in the results you see outside.
Right.
So that's how all those things are linked. And when you get new interesting field observations, that might spur you to do different lab experiments and vice versa. So they're all kind of cross-pollinating.
Right.
So we try to do a little bit of both.
Really fascinating. When do you hope to publish the findings?
Which ones?
Well, let's start with the harbor one.
Oh, well, that'll be a little while because we just got our preliminary samples out.
All right.
So within the next couple of years. Science it moves at its own pace.
Yeah, it does. It does.
Yeah.
But it's worth it in the end.
Of course. Well, yeah, I mean, that is my job. So.
And is there a hope in terms of how it might change what we do in a particular sense?
That particular project?
Yeah.
I mean, I would say that one is less, there's a lot of people who are focusing more specifically on issues to do with contamination of Hamilton Harbor, for example.
Right.
And that is really not our focus with this particular one. I would say the one that's most aligned with hopeful policy changes is our What's the Grime study, because it's directly related to people's lived experience. It's, sort of corroborating community concerns about deposition of soot to their properties, et cetera. So that's the one that's most obviously policy linked, I would say.
Do you get people in the community calling up you in the office or McMaster saying, hey, I got soot on my car?
Yes, actually.
Can you check it? Really, eh?
Yeah, no, I've gotten a couple, especially with this most recent one.
Yeah.
We had, when we started our first study, What's the Grime, we had over 200 or something applicants for 50 volunteer spaces to just host these little kits at their houses. They're supposed to be, they're very cheap. They're made out of like, I don't know if Dollarama sponsors this store, but this show, but like Dollarama little plastic, trays and things, and the idea was to make things less. I don't know what the word is. More accessible, I think, because we don't need to use complicated instrumentation to collect this stuff. Yeah. And so where was I going with this? Yes. And so we had 50 people, and now we are in the process of resubmitting a grant for a larger project that's going to be called What's the Grime 2, imaginatively, the sequel. There's more, but wait, there's more. And so we've had a lot of people interested in that. We're going to try and expand it out to 200 people. We're going to try and deal with some community questions as well. So people are interested in, how do I clean this stuff off my house?
Yeah.
Does it infiltrate into my indoor environment? The answer is yes. A lot of people can't keep their windows open. So we want to find out, how much does it go into their indoors, and how should they change their activities to, reduce the harm that they might be experiencing. And so where was I going with this? I forget what your original question was. I think I went a little bit
people calling
left
up
field.
to say, hey, we'd like to take part. Yeah.
Yes, thank you. Okay, I knew there was something. There was some core here to this question.
Yeah.
They were. So in terms of messages, there were the original enthusiasm about the study, but most recently with this soot event, I've gotten, I think, at least 3 emails directly to me, and I'm not listed as the immediate contact,
right.
saying, here's what's on my lawn. I'm going to be having coffee with one of the people who lives in my neighborhood. I was talking to a reporter from the Globe and Mail who lives in the neighborhood, and so people are very concerned. I think one of the issues is that these types of, I suppose, disparities in exposures and things become really obvious when there's literal black soot falling on people's yard, right? Yeah. It's more insidious when it's kind of the regular pollution, right, that you can't see as clearly.
Right.
It's the same with air pollution more generally, right? I mean, when we have these really smoky days, it's kind of like it's shining a light on the stuff that's always there. Like there's less of it, but it really makes it clear. If you have, if you sort of are doing dusting or something and you see the sun shining in and you're like, God, my house is filthy.
So dusty.
It's it's going everywhere, right? Yeah. It's like that, right? It just illuminates a situation that's already there.
Yeah.
And so I think that following the guidelines that come up during these time periods where it's difficult to not notice there's a problem, it's good to follow them as well. Like just check the AQHI before you're outdoors, running around and doing a marathon or something, right?
In regards to the recent soot incident, I think most people are concerned, is it harmful and where did it come from? Do you have any guesstimations on those two?
I mean, I can't tie anything to a specific industrial facility, but what I can say is that from our What's the Grime study, we know that what we can do is, when I said polycyclic aromatic hydrocarbons, pHs, there's a bunch of them. They're different things stuck together in different ways. And by looking at the population of those, like which kinds of them are there, you can get a sense of the sources of the emission. So for example, if you're burning wood, it looks a bit different compared to if you're burning coal, right? And so one of the things that we've been able to show is that the profile of those pHs is really consistent with coal combustion and coke combustion. So it's steel related. It's related to the emissions from there. And I mean, this is corroborated by the fact that people can see black stuff coming out of smokestacks. Most recently, I mean, it's not like it's always like that. But where was I going with this as well? No, I've forgotten. You asked.
In terms of the concerns of residents.
Oh, concerns. Yeah. I mean, I think there's a variety of different concerns. There's the concern that comes from people like me who are going out and measuring numbers, and saying, okay, there's this much of this stuff, and if we think that your child is crawling around and they touch this surface area, then they put their hand in the mouth this many times. This corresponds to this exposure. Right. And that exposure is more or less than from other sources. It's, and that's the numerical kind of dry end of things. But I think what's really more important is to think more holistically about the impacts of this, because to me, unless you've had this stuff falling on your house, it is extremely difficult to understand how psychologically damaging that is. I mean, I don't want to have to think about, and I'm not in the worst affected areas. I don't want to think about when my son's playing outside, don't touch the wall, don't touch things. This is a harm that I think is not something for me to express. This is a harm that's, the extent of it needs to be delineated by talking to people who live in these neighborhoods. Yeah. And I think that's kind of what's missing often from the scientific perspective on these questions. Like, this isn't a science question. A lot of things aren't science questions. Scientists can provide numbers, but they're really questions about equity and policy, right? And I think that's the thing, is often there's this sort of focus on the science numbers, but my science numbers are just saying what people in the communities have been saying since time immemorial, as I was saying. And there's no reason why me talking to you, like I'm the one on TV, right? But why? Like, I provide just one perspective.
Right.
Amongst many.
Many, yeah. Sarah, fascinating conversation. I felt like I learned a lot.
Oh, thanks.
Almost like I returned to school and learned so much.
That's very kind.
So appreciate your time and your analysis and insight on this.
Thank you so much. It was really nice to chat with you.
Absolutely. And that is a wrap for the Newsmakers podcast. A big thank you to the all-star cast behind the scenes. If you like today's episode, click the thumbs up, hit subscribe. You can leave a comment as well. Catch the Newsmakers podcast on chch.com/podcasts and wherever you get your favorite podcasts.